Okay, so the topic that got the most blockage in the past couple days is this one, predicting the qualitative acid-base properties of salts. All right, so let's read the question and try to figure what's going on. Consider the following data on some weak acids and bases right here. All right, so I've got a table with some acids and a table with some bases. All right, so acetic acid's got a Ka of 1.8 times 10 to the negative 5, and hypochlorous acid has got a Ka of 3.0 times 10 to the negative 8. What does this mean? Do you recall that the bigger the Ka, the stronger the acid, right? So this looks like this is going to be a stronger acid than hypochlorous acid. Okay, and here's a couple bases. Aniline, which is a formula of such and such, has a Kb of 4.3 times 10 to the negative 10, and hydroxylamine has got a Kb of 1.1 times 10 to the negative 8. So since this is bigger, right, this is going to be a stronger base. All right, so let's, now that we've just sort of read those tables, let's see what we're being asked to do. Use these data to rank the following solutions in order of increasing pH. In other words, put a 1 next to the solution that's going to have the lowest pH, that's the strongest acid, right? And a 2 next to the solution will have the next lowest, and so on. So it looks like there's 4 of them. So 4 is going to be the most basic, and 1 is going to be the most acidic. All right, so I do a quick scan of these things, and I go, uh-oh, none of these look like what I have up here. So I'm going to have to make some notes. So I've already made a couple notes over on my whiteboard. Let me take you over there now. What I'm going to show you on the whiteboard is that I've written out these data, and we're going to analyze them, okay? So these were the acids, right? Remember that from the previous table. I'm going to flip back and forth a couple times. Okay, so you've got your acids right here, right? And your bases here. So my acetic acid, and this is what acetic acid does in solution. It goes to acetate, and it has a Ka of 1.8 times 10 to the negative 5. Hypochlorous acid goes to hypochlorite, and it has a Ka of such and such, right? Well, we're being asked for pH here. So what I'm going to do, I'm going to make some notes here. I'm going to go to green. And if this is a base, recall that this means that this reacts with water, right, to make the conjugate acid of, I think this is aniline. So here's the conjugate acid, right, plus hydroxide, which I'm not going to write out there. And if this is a base, hydroxylamine, it's going to react with water, right, to make hydroxyl ammonium. You don't even have to know the name of that. You just know it tags an H plus on there, right? All right, so again, we're doing pHs. So I'm going to rewrite these two equations here. I'm going to say, well, what's the pH activity of this guy here? The pH activity of him is what? C6H5 NH3 and hydroxyl ammonium, just copying down that formula, right? That goes into, let's do the acid equation of this guy, right? This goes to aniline, back to aniline. Okay, and this goes to hydroxylamine. Okay, now recall that, and I've made another note here. Let's go to another page. Recall that Ka times Kb in an aqueous solution is 10 to the negative 14, and pH plus pOH is 14. Those two are the same statements, equivalent statements, all right? So let's go back over here and say, if the Kb of this reaction is 4.3 times 10 to the negative 10, the Ka of the opposite is going to be 10 to the 14 divided by 4.3 times 10 to the negative 10. And so that's going to be 2.33. Go back to red here for my acids, right? 2.33 times 10 to the negative 5. Okay? And this, the Ka of hydroxyl ammonium, is going to be 1 divided by 1.1 times 10 to the minus 8 is going to be 9.1 or 9.09 times 10 to the minus 7. All right, so let's go back over to our problem now. Now that we've got all these ranked, this is going to be the strongest acid. I'm going to do this in a different color yet. Let's do this in, well, I'll do it in black. Okay, so the strongest acid is the biggest of all these, and that's this one right here. That's going to be the strongest acid. Here's the next strongest acid, right, because that's the next biggest. And the next strongest acid yet is going to be this one, right? And next strongest acid can be that one, all right? We're going to have to go back and forth. So look at this. All right, so sure enough, there's my hydroxylamine. Recall, that's a bromine salt, or the bromide salt of that, right? So which one was that? That was number 3, okay? This is going to be basic. It's not even an acid. Here's an acid. That's basic, and this is basic. All right? And this is neither, right? Because that's nitrate. Nitrate is the conjugate. Nitrate is the conjugate acid, or rather the conjugate base of a strong acid. So that's going to be middle of the ground, middle road. So now that I got to do the ones I do another layer here. Okay, so sodium nitrate. What were the other ones? Ammonium bromide. Was it ammonium or no? Hydroxylammonium and hypochlorite and acetate. Okay, so this is an acid. This is an acid. This is going to be the lowest because it's an acid, right? These two are bases, so they're going to be above 7. And this is the conjugate base of a strong acid, and so it's essentially going to be middle of the ground. This is going to be neutral. Okay, so since these are both going to be basic, this is going to be number 2, and this was the strongest acid, so it's going to be the weakest base. So this is going to be the strongest base. I'm going to write this down here. Right? That was the strongest acid. When it was acetic acid, that was the strongest acid. So the conjugate base is going to be the weakest base. Okay? And therefore, this is going to be the strongest base. All right? And that'll be number 4. Then, because it's the strongest base, and this leaves us to be number 3. Right? You see that? Since this is an acid, it's going to be the lowest. And since these are both bases, this is going to be the next lowest. Right? And then I have to find the strongest base, and I do that. So it looks like it's going to be 1, 4, 3, and 2. Let's go back here. Which was number 1? That was the acid, right? And this was the next one, because it was neutral. And this was the strongest base. Okay, all right, so there we have it. Yes, I'm still here. I know I'm taking a long time. Okay, all right, hope that's helpful.